Now, what does radiation do to you? Why is it something that we need to avoid? Well, nuclear radiation is what we call ionizing radiation. So the high energy alpha, beta, and gamma radiation can create ions by knocking electrons out of chemical bonds. For example, when the ionizing radiation collides with water molecule, it can cause one of the electrons on the oxygen atom to break off, leaving this, whoops, I didn't draw that very well. Whoops, having problems. Draw, or it leaves a what's called a free radical, which is an unpaired electron. So you may not remember, we'll talk more about this later, what water really looks like. Well, a model of water. And there's two pairs of electrons on the oxygen. So what happens is the ionizing radiation can knock one of these off, leaving the water molecule looking like this, with just one electron instead of two. And that just one unpaired electron is called a free radical, and it's very reactive. Okay, so what happens then, there's a lot of water in your body. This water molecule then is very reactive, so it could collide with another water molecule, kick out an electron, and so on and so forth, until there's some sort of important bond broken. For example, in a DNA molecule or some other important structural molecules, and then it can cause tissue damage. The amount of damage is going to depend on how much radiation it comes in contact with the tissue in your body, or in plants as well, any kind of plant or animal that's exposed to radiation. Okay, so it could have no effect all the way up to a kind of the same effect as a burn, where bonds are broken, so it can be dangerous. So the types of units that are used to measure radiation, there's two different types of units. The Curie is the type of unit that's used to measure how much radiation is coming off of a radioactive sample. And 1 Curie equals 3.7 times 10 to the 10th disintegrations per second. So it doesn't matter whether it's alpha, beta, or gamma radiation, it's what's counted on a scintillation counter per second. So it's, the one, however, that's used to detect biological effects is the Sievert SV. And this particular unit relates to the amount of radiation energy that is absorbed by tissue. So a particular source can give off a lot of Curies, but how much is absorbed by tissue is another matter, because depending on the penetrating power of the radiation. This, you're assuming there's nothing interfering between the detector and the sample, so alpha, beta, and gamma would just be measuring how much radioactive energy is being given off, whereas in this case it's how much is actually making it to tissue, to damage tissue. Depends on the penetrating power.